Hi, I'm Olivia and I'm on the product team here at Vi14. Today I'm going to show you how to build APIs on top of your OLAP data with Moose. So let's just get into it. I have a ClickHouse database here and I'm just going to flash up the table that we're going to query from. I have this data of completely fake people, fake names, birthdays, ages, age groups. And I want to expose this data to a front-end application so that I can explore this data in a more engaging and interactive user interface. So if I open my dashboard, what I have here is a histogram that I can adjust based on the criteria for the distribution that I want to see. So in this view, I'm able to see the age category of all of the people in my table. And if I toggle my distribution type to age, I'm able to see a histogram of the raw ages in my age column here. So in order to make this dashboard work, I need to be able to expose this table data over an API and integrate my front end with that API. So if this data were in a transactional database like Postgres, for example, that's a very straightforward task because there are plenty of ORMs and frameworks that I can use to get that done very quickly. Because my data is in ClickHouse, which is an OLAP database, I don't have the same luxury of a very developed ecosystem of tooling to leverage. And that's exactly the problem that Moose is trying to solve. Now, I'm going to show you kind of the status quo of how I would achieve this exact functionality without Moose. So here's an example of the same API that we're going to go ahead and build in Moose, but this is using the Express.js framework for my web server. And then I'm also using Zod to make sure my query parameter validation is accounted for. What you might notice by immediately looking at this file is I have 55 lines of code here, but if I really just focus in on kind of the core intention of my API, that's only about 11 lines, so really a fifth of this entire file. And because my API logic is drowning in a bunch of boilerplate, that doesn't only add a ton of surface area for me to have to maintain every time I want to make adjustments to my API, like adding or changing a query parameter, but it makes my code really hard to read. So with Moose, the goal is to make this experience a lot better and deliver the same ergonomics, smooth, kind of frictionless developer experience we've come to know and love with some of the tooling that we have in the transactional world, but bring it to the OLAP ecosystem. So let's get into our Moose project here. I have an API folder within my Moose app parent folder, and inside this folder is where I can define my APIs. Moose uses file-based routing, so if I just wanted to create a new API route, all I have to do is create a new file in my API folder. So let's do get age distribution as our route name. And again, that's just our file name. And now we're ready to go. So I'm gonna get set up with a few imports here. I'm gonna import create consumption API and the consumption helpers module from MooseLib. And now we can define our query params. So in this example, we're just gonna have one query parameter and we define it using a regular TypeScript interface and using plain old TypeScript typing. So let's set our query parameter to distribution type and we'll make that optional and we just use the optional operator to denote that. And then for our type definition, we can use just regular old union typing. So we can make our distribution type either age or age group, and this is how we'll return our results. Now, to tell Moose that I want to have this query params interface used for kind of automatically deriving my parsing, validation, and error handling, what I have to do is just pass it in as this type to my create consumption API wrapper function that I imported from mooselib. Just by doing that and just by defining my query params and my types as a regular interface, Moose is able to pretty magically generate all of my runtime validation code, my error handling, and all of my parsing for me. So I don't have to worry about any of that boilerplate. Now, inside of the create consumption API wrapper function is where I define my route handler. And in this function definition, you might notice it is an async function. I can pass in my query parameter and set a default value. Again, this is how you always set default values for function arguments in a TypeScript function. And then I'm also gonna make sure I have access to my database client and a SQL tag template helper that Moose manages for me. So this helps me because I can just write my queries in a regular TypeScript template string where I can safely inject my query parameters and other dynamic components, and I don't have to worry that my code is going to be prone to SQL injection. So let's go ahead and write our query. So we're going to select the column that we passed in as the distribution type query param, and maybe we can go split screen here to show the different columns that we're working with here. And then we're going to group by our chosen column and then take the count of all of the different number of rows for each grouping. And then if our chosen distribution type is age, we're gonna also add an order by clause so that we make sure our return data is in ascending order. It doesn't really matter for the age group because we only have 3 categories. So now we'll just make sure that our query is executed and the result is returned to the client. When I save this, let's just make sure that my file watcher picked up on the change, and as we can see it did, so I'm good to test. I'm gonna open up an API client here and start hitting the API. So first, again, my query parameters is optional. So if I don't send any query parameter in my request, I should expect the age group criteria to be the default behavior, and that's exactly what we're seeing here. If I switch my distribution type to age and hit my API again, you'll notice that I not only see the age distribution, but my results are returned in ascending order like we would expect. Finally, to show you a bit of a preview of how the automatic error handling and type validation works at runtime, I'm gonna just send a parameter that does not actually adhere to my type definition. So let's just set a random string, let's say blah, as the value of our distribution type, so you can see an example of the kind of automated error handling that Moose takes care of for you. So I get a 400 bad request as my response, which helps me as the person integrating with the API know that I made a mistake in my request. And then I also get a really helpful error message that tells me I have sent an invalid value for my distribution type, and it also gives me a list of the expected values that I can pass in. So that's APIs in a nutshell. Stay tuned for the next one where I'll walk through how to get even more advanced type definitions and some other cool features like auto-generated open API documentation. But thanks for watching this one.